Okay, so we're going to learn the types of equations using the situations that we had up here. So the first one is called synthesis. You'll want to write these down if you haven't already on some notes somewhere. Because you won't have any paper on there. So write some on these notes. No, that's for scratch paper we're going to use in a minute. If you need some extra scratch paper, there's always some back by that green crate back in the back. Okay, so synthesis is boy meets girl. A plus B gives AB. Now, the boys are going to be representative of the metals on the periodic table. So that's that diagonal line between boron and unoctium and below. So that's the S, the D, the F, and the lower part of the P. The girls are going to be represented by the diagonal line from boron to unoctium and above. Those are the nonmetals. Okay? So I have a metal plus a nonmetal gives me a compound, an ionic compound. That's synthesis. Then we had, decomposition. Decomposition took that couple and split it up into pieces. Okay, so decomposition. The next one that we had was single replacement. Some places call it displacement. And you know it just means the same thing. Sometimes you're dissed and sometimes you're replaced. Okay? A, B plus C yields CB plus A, or AB plus D yields AD plus B. So those are representative. Okay? So single replaced. Next one that we did was double displacement. Again, dis could be re, where you had AB plus CD yields AD plus CB. You traded partners. Okay, now underneath double displacement, we also have, so this is sort of like an indent, there's a special kind of double displacement, and it's called acid-base. And I usually put strong acid, strong base, but you'll learn that later. It has where you have a hydrogen and something, so an acid, plus something and an OH, that's a base. It gives you water plus something else that we call a salt. It's a neutralization reaction, so an acid-base reaction. Also known as a neutralization because you get salt and water. Neutralized. The last type is called combustion. This is one of the most favorite of all high school students because you get to blow things up, catch things on fire. Combustion. Okay, so combustion is some kind of carbon, some amount of carbon, some amount of hydrogen. Also in this, I'm also going to put over here, you could have nitrogen and you could have oxygen. Okay, but you don't have to as part of this. And you're going to have oxygen because you need something to combust, and you're going to end up with H2O and CO2. Now, this time of year, the fire departments also are telling everybody to check this monitor because if you have incomplete combustion, you don't end up with CO2, you end up with carbon monoxide. It is. It just you feel like you have the flu. You get a headache, you get nauseous, you feel like you don't need to sleep, and that's why it's called the silent killer, because you just think you have the cold. Okay? Okay, so let's go on. Grab your voyage and keep this where you can see it because you're going to need it. Okay, so we're going to section 1 of the voyage. We're going to apply what we just learned. Okay, so here we go. On question number 1 here, we have a couple plus a couple yields a new couple and a new couple. What type? Double displacement or double replacement? No, I want you to write it out here. We'll have other ones I'll let you do the shortened name, but I want you to write it out on this one. Double replacement or double displacement, same thing. Okay? So what would the next one be? Double displacement again. What about number 3? Combustion. How did you get combustion, Kyle? There's a CO2 and H2O on the product side. That's a hint. And then you've got an O2 and a carbon compound. So this is combustion. I'm going to do that black. Okay, what about number 4? Single replacement. A single and a couple, new couple and a single. Again, you could put replacement or displacement. Either one works. What about number 5? How'd you get that? It's 1 and then it's broken up, so that is decomposition. Good job. Okay, I want you to do the rest. I'm going to ask people to come up and put it on the board. So take a minute and work on 6 through the end. Okay, we're going to start with number 2. I am going to take my paper, just like the scratch paper that I gave you, and I'm going to put it right here. That's what I want you to do. So I just want number 2. Everything else but number 2 covered. Okay, we're going to come back to number 1. We're okay. Okay, underneath the arrow, this is what you need to do. You need to write every element that you have in here, leaving oxygen to very last and hydrogen to second to last. So you always end up ho, 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 just like Christmas time, right? Okay, so Na, I, Pb, S, O. And it's going to be like a teeter-totter. We cannot create or destroy matter. Because we cannot create or destroy matter, whatever I started with, I've got to end with. Okay? So what we're going to do here is look on the left and we have 1 sodium. And we look on the right and we have 2 sodiums. That's the first place I need to stop. They have to be the same. I can only change it by putting coefficients. So I put a 2 right here. I now have 2 sodiums and 2 sodiums. Now, by the way, I would do this in pencil because you're going to be erasing and redoing. Okay? On this side now, the 2 goes through to the iodine, so I have 2 iodine. But on the right side, how many iodine do I have?
4.
4. Now I got to go back and change this from a 2 to a 4. When I do that, it affects here and here. You see that? Okay, we'll go back. Okay, look at this again. Whoa, hello, come on back forward. Go back. Okay, it's not going to go all the way back. This was a 2, right? Everybody okay with that? That's where we were. Okay, now, yes. I just put a 2 in front. Just put a 2 in front. Okay, so now I have 4 iodines on my right-hand side. I need 4 iodines on my left-hand side. So I have to change this from a 2 to a 4 to make it 4 iodines. When I do that, that changes this, but it also affects my sodium. And I have to go back and fix my sodium. On the left-hand side, I have 4 now for my sodium. I need 4 over here on my right-hand side, so I'm going to put a 2, because 2 times 2 is 4, and that's going to give me my 4. Okay, now I go and check the rest. My lead on the left is 1. My lead on the right is 1. My sulfur on the left is 2 times 1, which is 2. My sulfur on the right is 2 times 1, which is 2. My oxygen on the left is 4 times 2, which is 8. And my oxygen on the left is 2 times 4, which is, and I'm balanced. I don't write any ones. I don't write any ones. Okay? Let's try another one. Let's go on to the next one. Number 3. And I'm going to take my paper and I'm going to find another clean piece. Sometimes I fold it, sometimes I turn it, whatever you want to do. Again, writing down the center where the arrow is, all the elements in that equation, leaving ho, ho, ho to last. Okay, looking at the left, how many nitrogens? 1. How many on the right? How many hydrogens on the left? How many hydrogens on the right? Good. Now that's a place where I need to stop because they're not the same. I need to find a common factor between 2 and 3. We've done that. 6. So that means on the left-hand side, I'm going to have to times it by 2. That'll make that 6, but that messes with my nitrogen, making it 2. I'm not going to do anything with nitrogen yet until I fix the other side. Hydrogen, I need to times by what on the right? 3. Did it affect the nitrogen? No, it didn't affect the nitrogen on the right-hand side because there's nothing in front of the nitrogen there. Okay, so I now need to go back and fix my nitrogen because on the left there's 2, on the right there's still only 1, so I put a 2 right here. Okay, now my nitrogens and my hydrogens are okay. Everybody all right with that? Okay, now I'm looking at my oxygens. On the left, how many oxygens do I have? 2. How many on the right? Careful, I have 2 with the NO, plus I have 3 with the water. Gives me a total of 5. Okay, now how in the heck am I going to get a 5 on the left-hand side? Because whatever number I put in front of oxygen, it's going to have to be times by 2. So here's a little trick. It often happens when you have an O2 by itself. You put just for a second, I can't leave it that way, but just for a second I put 5 halves. That'll make 5 oxygens there, right? Because 5 halves times 2 is 5. But I can't leave it there. So how in math do I get rid of a fraction? Times the whole thing by 2. So I'm going to go back and times the whole thing by 2. So that 2 changes to a 4. This 5 halves changes to a 5. This 2 changes to a 4. This 3 changes to a 6, and I'm done. Now we're going to go back to number 1. Okay? So let's go back to number 1. Everybody got this one down? Okay, we're going to, it's just practice, guys. It just takes a lot of practice. Okay, so number 1, here we go. I'm going to do that again. I'm going to take my paper, put it right there so I don't see any of these others. And my paper doesn't want to be a paper today. Okay, same thing. Underneath the arrow, put carbon, and then I end in ho, ho, ho. Okay, side to side. How many carbons on the left-hand side? How many on the right? 1. So, what do I need to do? 6 in front. Good. So I now have 6. Hydrogens, how many on the left? 6. How many on the right? 2. What do I need to do? Put a 3 in front of it. Good. That makes 6. Now we're going to do the oxygens. How many oxygens on the left? 2. How many on the right? Be careful. 3 with the water. 12 more with the carbon dioxide, giving me a total of 15. Okay, I'm going to use my little trick again. What do I need to put in front of the oxygen on the left-hand side? 15 halves. Because that times 2 is going to give me 15. It's balanced, but I can't leave the fraction. What was the next step I needed to do? Times everything by 2. So this becomes a 2. This becomes a 15. Good. This becomes a 6. This becomes a 12. Good. Okay. All right. What number were we on? Going down. 4. Let's go down to 4. Okay, put my paper across again. Hopefully it draws itself. Nope. Okay, it doesn't want to go. So we have Fe, H, and O. How many Fe on the left? 1. How many on the right? Okay, what do I need to do? Put a 2 in front of the left one, right? Now I've got 2. Okay, hydrogen. It's going to be a little tricky here because we're going to have to go 2 times the 3 to get how many hydrogens, right? You see that? 2 times the 3? So that's 6. And over here we've got 3 with the Fe plus 1 more with the oxygen giving me 4. Now this is right. I write it like I do. Is there a way for me to get 6 by just messing with one of these? 3 here, 1 here. Oh, hydrogens. Oh, sorry. I'm down to oxygens. Okay, let's try again. 2 hydrogens. Thank you. I'm a step ahead. So 2 hydrogens. How am I going to get that to 6? Multiply by 3. Now I've got 6, and that oxygen will take care of itself now. So over here I've got 2 times 3 for oxygen again, so 6. Over here I've got 3 plus 3 giving me 6. It's balanced. Okay, now your turn. Keep going. Or do you want to do one more?
One more.
One more. Okay, we'll do one more. Okay, here we go. Number 5. Okay, underneath the arrow, again, I'm leaving HO to last. So nitrogen, magnesium, H, and O. Don't take that wrong. Ho, 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 like Santa Claus. Sorry. Okay, nitrogen. How many on the left? 1, right? Just 1. That 3 doesn't come through because it's not in parentheses. What about on the right, though? That 2 does come through. Well, there's 2, so what do I need to do? Put a 2 in front right here. That'll give me 2. How many magnesiums on the left? 1. How many on the right? How many hydrogens on the left? Well, I've got 2 in that first one plus 2 in that second one. That gives me 4. How many do I have on the right-hand side? 2. So I'm going to have to change that and make it 4. Okay, oxygens. Let's hope they worked out. How many on the left-hand side? 2 times 3 is 6 plus 2 times 1 is 2, giving me a total of 8. On the right-hand side, 2 times 1 is 2, plus 2 times 6 is 3 is 6. It's 8, and we're done. Yes? How come we didn't times everything by 4 when? So you just pick one at a time, just one thing at a time. And I only times what I need to. Okay? All right.